Hey there! Today you guys are going to be completing your Math 8 weekly homework assignment. And in the grade book, it's going to be Star Math 27. I do want to say that if you are having any trouble with any of these questions or you need additional support, please make sure that you sign up with your teacher during their office hours on Mondays from 1 p.m. to 2 p.m. or during Rater Prep. Let's get started. Number 1, which of the following set of numbers contain only rational numbers? All right, so let's take a look at answer choice A. In answer choice A, we have -3/10, the square root of 25, and pi. We want to take a look for which one has rational numbers. And as a quick refresher, all rational numbers are natural, whole, integer, and all of those numbers are rational. And inside rational numbers, it also contains percents, fractions, and terminating decimals, or decimals that repeat. So when we take a look at these three answer choices in A, we have -3/10. Well, because that's a fraction, this is automatically rational. The square root of 25 equals 5. 5 is a natural number, and remember, all natural numbers are rational. And then we have the symbol pi here, and that's actually an irrational number. That means answer choice A is not our answer. In B, we have 0.55. That line means that it repeats. It's a rational number. Square root of 49 is 7. That's also rational. -0.387 ... The ... represents that this is an irrational number. Answer choice B is not your answer. In answer choice C, we have the square root of 11. The square root of 11 is not a natural number. If you plug it into decimals, you're going to get some crazy number. This is actually irrational. Answer choice C is not your answer. In answer choice D, we have 0.8989. The line above that means that it repeats. A repeating decimal is rational. -0.33, the decimal stops. That's a rational number. A fraction is rational. So the only answer choice here that contains all rational numbers is D. Number 2, what is the value of the expression if x equals 3, y equals -5, and z equals 2? All right, this one I'm actually going to use Desmos for. And one thing I need to remember is when I am plugging this into Desmos, I do need to plug it in exactly as I see it. So it was z, and I opened up a set of parentheses, which was just a bracket, but I'm going to use parentheses here. X squared minus x. Open up another set of parentheses, absolute value of y, plus 1. I'm going to close both parentheses, and that's plus the square root of 144. So now I need to let Desmos identify what x, y, and z are. So it said that x equaled 3, y equaled -5, and z equaled 2. Up here, in the line where I wrote my expression, I noticed that my answer is -6. So if I go back to my answer choices, I can say that answer choice B is my answer. Number 3, simplify the following expression. Okay, so I'm going to do this two different ways. The first way I'm going to do is by hand, and then I'm going to show you how we can use Desmos to verify our answer. So because I see this a positive 3 attached to our set of parentheses, that indicates that I need to do the distributive property. So I don't do anything to the -5x, so I bring it down. +3 times a +2x is +6x. +3 plus 7 is 21. I'm going to bring down my -8x plus 12. Now what I need to do is I need to put numbers together that are like. I I can put my negative 5x together with my 6x and with my negative 8x. I can also put my positive 21 with my positive 12. So I'm going to go ahead now and I'm going to combine those. So I have negative 5 plus 6 minus 8. And we can use Desmos here. Negative 5 plus 6 minus 8. I notice that that gives me negative 7. So I'm going to say negative 7x. 21 plus 12. It looks like it gives me a 33. And it looks like I'm left with answer choice D. But what I'm going to go ahead and do is I'm going to go verify my solution in Desmos. In line 1, I'm going to type in the expression that they gave us. And I'm going to make sure that I type it in exactly the way that it is written on my paper. In line 2, I'm going to go ahead and I'm going to type in the answer that I got. And in the third line, I want to make up some large number to let it equal x. And when I take a look at line 1 and line 2, I notice that both lines are equal to one another. That means that I solved this correctly and that my answer is D. Number 4. Is the sum of negative 4/9 and negative square root of 361 rational or irrational? All right. So the first thing that I need to remember here has to do with the good oranges and the bad oranges. Anytime you had a bad orange, which we represented as irrational, you were always left with a bad orange, which we would say the answer is irrational. But if we think about what a rational number is, well, we have a fraction here. A fraction is always rational. And the negative square root of 361, well, if you're unsure what negative square root of 361 is, we can type that into Desmos. And we notice we get negative 19. Well, negative 19 is an integer, which automatically makes it a rational number. Notice that because I have nowhere in there where it says irrational, I have two rational numbers. That means that I am left with another rational number. Number 5. Which does not best describe the number negative 12 divided by 4? All right. So the one thing that I have to remember here, we kind of already touched upon this in question number 1, but we have to remember what our Venn diagram looks like for the real number system. We know we always start with natural numbers. We know that every natural number is a whole number. Every whole number is an integer. Every integer is rational. We know that all of these numbers are always real. And then we always have irrational numbers out here. Those are our crazy numbers that we put together. So let's take a look. First of all, it says which one does not best describe the number negative 12 divided by 4. Well, if we simplify that, that gives us negative 3. Well, if we're taking a look here, where would negative 3 fall within our real number system? We know that it's an integer. Well, we know that every integer is a rational number, and we know that all rational numbers are real. So we know, just by taking a look at our answer choices, that negative 3 is an integer, it is a rational number, and it is also real. Because the whole number falls below an integer, we know that our arrow can never go down. That means we know that negative 3 will never be a whole number.